And you have to what? Rotate around the cross? I can take one with you. Oh, here.
Hello, everybody. This is going to be TSVWG. It feels very high up here. We'll get used to this. We require some people to help us with notes. Does anybody in the room feel able to take a few notes for us? Notes are always appreciated. We're happy to take whatever we're provided with and make sure that all the little bits and pieces are correct. So it's just really, really useful to have a note taker who provides us with that starting point, because we may forget something and we really can't have the meeting not being recorded. Brian, thank you. Get this slide.
Okay, and we have a second note taker. Ying Zhen has agreed to also take notes for his addition to Brian. Thank you very, very much.
The Etherpad is slightly dodgy today. I don't know, they changed something on the back end and the links don't work. So like reload twice and it works fine.
All right. Okay. I think we're 5 minutes after, so we probably need to get started.
So, let's see where we want this. I'm Gori Fairhurst. I'm one of the co-chairs here, and this is
David Black, your other TSVWG co-chair. Wes Eddy, our third co-chair, is on Meet Echo and will doubtless be speaking up as we go along here. This is the usual note well with the usual warnings. Please make sure you've read it at least once. It does apply to everything that happens in this meeting. Okay, we have taken care of note takers, Brian and Ying Zhen, and Mike Abramson has agreed to handle jabber scribing. Thank you, folks. Quick reminder: there's been a bunch of reviews on the list. Please, more of the same. Reviews are what makes what makes the IETF function. And remember to put TSVWG in the name of any draft that you'd like working group chairs to pay attention to. General reminder that reviews are important. If you'd like your document to progress, please review other documents, and with luck, other people will return the favor and review yours. Okay. Now we get to the important administrative stuff. Progress and status. So we've had an RFC published since the last IETF. This is RFC 80. It's RFC, I think it's 8540 is the actual number, but I will have to go fix that slide. I clearly made it too late last. In any case, the eroding issues draft has been published, and I have to go fix that slide. The diff-serve lower effort PHP draft is at the RFC editor after about 4 times as much elapsed time as we thought it would take. Thank you very much, Roland, for putting up with this and getting it done. In addition, the diff-serve and WebRTC QoS draft is at the RFC editor. This is going to sound like a broken record because it's part of the well-known WebRTC cluster 238 that at some point will finally emerge for the RFC editor. Our new AD says it's getting close. He's inherited part of this. We have 2 IDs, the ISG, which we're going to talk about in a little bit as part of chairs. What happened is that the FEC drafts are basically done. Good work. However, they ran into a process hiccup at the IESG concerning a piece of code that is absolutely crucial to implementing it. That's being cleaned up, but they're at the IESG, and when we get we'll talk a little bit more about how we're going to clean that up. Okay, we still intend to send a couple of drafts to Working Group Last Call soon. I think this is like the 3rd IETF meeting in which we've done this. We somehow have to figure out how to get these to Working Group Last Call. This is my problem in that I was supposed to Working Group Last Call and I've had other things consuming my time. Okay, go ahead.
this will happen after this IETF.
I think Gori just threatened me with a broadsword.
After this IETF goes on for a very long time.
Okay, 9 more drafts in the working group. Not going to read the entire list. Okay, now we get to go with a survey of related drafts that may be of interest. There are a couple of drafts over in 6-man on path MQ discovery for IPv6. The L4S and DiffServ draft, one of Bob's draft, is before this working group. We're not going to be talking about it this time, but it's worth having a look at. It is a fairly important concept. Likewise, the DiffServ to QCI mapping for cell phones.
We didn't hear a lot more about that one since we last talked about it, so might need to update that if you're going to keep it on the list.
Okay. There was a presentation at Hot RFC session on loops, which is the successor to an overlay forwarding draft that we briefly looked at last time. Iju, when is the side meeting for that one?
It's Wednesday afternoon, 1:45 p.m. at Athens and Barcelona. Thanks.
Okay, so that's the loops draft. There is Tom Herbert's been running a bunch of drafts. We've got a UDP space header draft and several GUI drafts over in int area. For the most part, pay attention to the int area working group as a primary forum for these, at least for now. If something changes, we'll let you know. All right. The ECN for NSH draft in SFC. Oh, what an acronym soup. Is now an official working group draft over there that is related to the tunnel congestion feedback draft. As that draft moves forward in SFC, there's a very good chance that we'll bring the tunnel congestion feedback draft back up here and move that forward as underlying mechanism. There's an informational draft on low latency DOCSIS, for those who are interested in that. Stuff over in int area. There is a tunnels draft, a draft on fragmentation for fragility, and SOX protocol version 6, which is an internet draft is being discussed over there. Okay, on to the agenda. You're in the middle of the chair's slides. We've read the note well. Done document accomplishment status. Milestones review, drafts, and more drafts are coming up. We can go bash the agenda as we go along if there's any changes we need. And I think that's the last minute slide arranging, right?
Yep.
Yep. Okay. Monday's not the. When you start on Monday, it's often the case that slides don't come in all that far in advance. Oh well.
But if you're on the agenda, please send us something. I'd much rather have somebody walking up now wanting a small update than to have no slides in the deck. So if we have a Monday meeting, please send us stuff before the meeting.
Okay. Milestones review. Okay, so the first two milestones in yellow or orange, whatever color that's showing up as, are the two ECN encapsulation drafts. Those need to be last called. If anybody's interested in being a shepherd for the drafts, please let us know, because the existing shepherd, that would be yours truly, hasn't been particularly diligent or attentive. But we will get these drafts called one way or another last call before the next IETF. Other stuff is supposed to happen for the next IETF. We're kind of optimistic here. I'm sorry. We're going to pull it over here. Other stuff is supposed to happen for the next IETF. SCTP NAT draft, we'll talk about that tomorrow. Transfer options UDP, we'll talk about that tomorrow. The 3 L4S drafts, we'll talk about those today. And then after the next IETF, packetization, MQ discovery for datagram, and the transport header encryption draft before the third IETF this year. Then after that, sometime the next version of SCTP. I'm not sure how good an estimate that end of year milestone is. That's what we're working from now. And tunnel congestion feedback, again, that's a guesstimate. So that's where the milestones stand. And the big one we will have to figure out is what we're going to do with the big one we'll have to figure out is how we're going to make sure that the two ECN encapsulation, which is layered ECN drafts, actually do go through working group last call in the next cycle. We've got a whole bunch of stuff that is on the list to be done between now and the next IETF. Okay. So, all right. So, okay. So the agenda for today. So this is the opportunity to bash the agenda. We're right now on item 1, which is document status, charter, and accomplishments. You'll see agenda bash. This is agenda bashing a hackathon update. We'll cue the hackathon update just after I quickly run through these slides. Then we do transfer header encryption, followed by L4S, followed by some congestion experience, the non-queue building flows draft, and multipath DCCP if there's time left over. A primary purpose of this meeting is to get some clarity on what's going on with both the L4S and the some congestion experienced topics. Then on Wednesday, there's only I think there's only a part 1. I don't think there's a part 2 to this. We have the SCTP drafts, which is both the NAT draft and the plan for the next version of RFC 4960, and datagram MTU discovery, UDP options, and if time permits, a couple of presentations on proposed new work. One is HTTP2 as a transport, and the other is the SCTP SCTP retransmit bit. Okay. Anybody want to bash the agenda? And I need to go clear revise these slides, if nothing else, to fix that RFC number goof on the SCTP errata RFC. All right. Consider the agenda bashed. Hackathon update. In particular, somebody should say something about TCP Prague.
For the hackathon update, we have no slides, but we do have some moments of time. Does anybody want to come to the mic and say something about any of the activity that they've done at the hackathon? A few words just to call out stuff would be helpful.
Okay, Olivia Tillman's arranged a bunch of people to work on L4S things, TCP Prague, surprisingly also Quick Prague. That surprised me, and that's been built already, which is a L4S version of Quick with an L4S congestion controller and feedback in it. TCP Prague being built, and the main thing they were doing at the hackathon was working out how to work with software generic receive offload and segmentation offload, sender segmentation offload, sort of patching the Linux offload engine. Built a virtual test environment for it all as well, and did a bit of interworking testing and things. So made a lot of progress. I was really very happy with them all.
Thanks, Bob.
It was about 8-10 people doing it.
Tom Jones, University of Aberdeen. Just an update on the related stuff from 6man on PathMT discovery. We had 7 people working on implementations. We got a Linux user space implementation working, a Wireshark dissector, and 2 router implementations working, so VPP and P4. And so this is really good progress. What still remains to be seen is how we integrate these signals into transport and what we do with them, but it was a good, strong start and there was a lot of interest.
Thanks, Tom.
Hi, it's Jake Holland. I had a couple specific questions regarding TCP Prague at the hackathon. Was any work done, does anybody know if any work was done on, there's a few requirements in the L4S draft about, I believe, the accurate ECN and the rack support in the endpoints. And so I was curious as to whether any issues were attempted, addressed, encountered along the implementation path. Thank you.
Yeah, sorry, this is Bob Briscoe again. No, you're right. I was didn't have a script, so I forgot the accurate ECN bit.
But Mira said we should remember to talk about it. So go ahead, Bob.
Yes, that was largely where all the TSO GRO stuff. It was accurate ECN where that was all the issue, and that was there was some subtle interactions we found between accurate ECN and the Linux code, which is what they were trying to sort out. I can go into detail if you want, but it's probably for just those that are interested. I can do it afterwards rather than right now. Yeah. Okay.
Thanks.
Yeah, and I should say that accurate ECN is not only for L4S, and so that is now, there's an implementation of that, and it's available. It's part of the L4S tree, but it's another branch.
Okay. Thank you.
Okay, so we need to get. All right, hang on. Let's go see what we do here.
So we have a one-slide update from the chairs on the FEC frame RLC story. I guess I could easily tell you about this, but Vincent could also tell you in 2 minutes, and that would be much more efficient, I think. Vincent, come tell us in 2 minutes what's been happening. It's good.
Yes, very quickly. So we updated these two drafts quickly, taking into account ISG comments. I think we cleared all the issues, technical issues. There was one big issue remaining concerning the licensing copyrights for this source code. So the solution, the good solution was to remove this source code, C source code from the draft and move it to an additional draft that would be co-authored with the two Japanese researchers who designed this PRNG. So this is what we've done, and thereby all the license and the copyright is cleared because it's now the IETF trust stuff. So there's no problem from this point of view anymore. There were a few remaining technical aspects in this C implementation that might compromise interoperability. It's about issue in specifying how to what is the negative format for C. So there was some ambiguity here. So we cleared also this issue by doing it in slightly different way. So from my point of view, everything is now is now correct, and we therefore have this normative dependency from the RLC FEC scheme internet draft to this TNMT 42 internet draft. So now I give you the floor.
Thanks, Vincent.
You're welcome.
Yeah, Spencer Dawkins, Responsible Area Director for this draft. Thank you for chasing this down. This was, like I said, just for the community, this is a complicated thing where we say we have to have this particular copyright statement in a part of the draft, where somebody else has to have the other specific statement, and it's not totally obvious how we mix and match those. Thank you for doing the homework to make that possible for this draft. The other thing I wanted to mention that came up as a late surprise during ISG evaluation was the thing about how portable is this code.
Yep.
And that was not something that anybody who had looked at it was looking for before it got to the ISG. And I don't see that happen. So I was on the ISG for 6 years. I haven't seen that happen before. So it doesn't happen often, but just something for people to be aware of is that there was that concern about how portable the code would be in different environments that you had to chase down too. And I wanted to thank you for doing that also. But like I say, just for other people to be aware.
Yeah, and thank you to ISG to identify such issues, because I was not aware of this to complement stuff not being specified normatively in the C specification, as C99 or whatever you may think about concerning C language specification. So that was great also from a very good feedback from ISD.
Okay, if you're interested, please talk to Vincent or read the drafts, and we hope to see this progressing quite quickly now.
In addition, the fixed chair slides are now uploaded, and so I think we've actually got all the slides for this session. Okay. Oh, you're going to be virtual, Colin? Yeah, you want?
Hi, I'm Gori Fairhurst. As an author this time. Oh, and you want me to click? Okay, I'm going to be talking about the draft that's entitled "The Impact of Transport Header Confidentiality on Network Operations and Evolution of the Internet." The intention of this draft is to talk about network operation history, what's been done in the past, and what we think might be factors that impact the evolution of the internet, meaning transport evolution, because it's a transport draft. We're currently at draft Rev 5. Okay, and
when you click, I'll center.
Whatever. We got a review from Sector of this draft because we think it's nearly finished. And in the review, the first line of text said the document lays out a comprehensive assessment of the impact of transport header encryption on network users and operators, which was exactly our goal. So that is now the goal of this draft. Next one. Am I doing this? Oh, you're whatever.
All right, just call next slide.
So this draft's had a history, and here are the various points in history. Many versions were gone through before it reached the working group status, and since working group status, we've received comments from the working group. We asked for the working group to put this forward for publication. At that point, we got sector review, and we asked for art review as well, which we're still currently pending as David tweaks this. Since then, we've had a number of updates responding to these comments, and other people have chipped in on the list, and that's very much appreciated to get this a readable document. Next page, please. When we got the sector review, they had a few comments. Here we all go. There were lots of comments. The document, they said, had issues, which is fair enough. We wanted more input, so that was good. So we added some text on TLS, on the TLS story. We probably added less text than we could, but we added as much as we were brave enough to do, and we think it's sufficient. So that's me telling you the working group. If you think different, then please suggest a few extra sentences that you think are really important. We'll happily add them. We made lots of sections clearer. Obviously, it was great to get security inputs on a document that talks about security, and the use of words is somewhat different to the transport areas. So now, hopefully, things match both sides. Flow labels proved to be more contentious than we expected because transport and int people didn't think they were contentious, and security people wondered about this. So in the end, we decided we wouldn't make opinions on this. We would simply cite the current published PSs and BCPs that refer to these, and they said more or less the right things. So we rephrased and we used that. Added text on the spin bit work in Quick. Because by the time we got to this stage, that was now part of the Quick specification, so that's good. Added section on endpoint logs. We didn't add much on endpoint logs because I don't think endpoint logs particularly help you in finding out how the network treats your packets, but they do help you debug a transport protocol when you want to find out what the other end's doing, as you'll find out if you go to the Quick working group. So we now reference this. Made a separate section. Oh yeah, we made a separate section on research and development because I think that's actually an important topic as we move forward. What is the impact of encryption on the research community, or the way in which we develop standards here? And it's not the same as on operators. It's a different community who've been closely linked with transport over the years, and we have to figure out how we go forward. So we don't provide solutions. We don't even identify the real problems, but we say this is what was done. And now we need to think. And we added more references. We got lots of comments from people individually, and we hope we addressed them all. We didn't add speculation about new proposals that were going on in the IETF or IRTF. We're aware of stuff like in the Privacy Enhancing Research Group, which might be really relevant, but currently it's not received much attention in the IETF. It's a big room when it met this time, so it would be exciting to see this happen in future, but we don't really have operational experience for that. And we didn't also comment on things that are presented in MapRG, which were things in progress, which will naturally mature over the years. I suggest you go and look at these groups if you're interested in this, because there's lots of good things going on. Next slide, please. Well, we may wish to bash the summary at the end of the document again, but we don't really have much on our to-do list. Next slide, please. So, anybody got questions, comments, or opinions? Our suggestion is that we would like more feedback, and if people provide feedback, we would love to hear from them.
Aaron Falk. I'm sitting in the wrong chair because I have not read the draft, but I was wondering if you could clarify the intent of the document. Are you trying to make recommendations?
No.
You're just trying to describe the state of the world?
We're trying to explain the sort of impacts that might have if you look forward. That's not making recommendations about how to get to that place, but it's just saying in the past, people did this, and they had a reason for doing it, which was that. Now, you might not be able to do that, but you still may have that reason, and it's left at that point. I mean, we would like to follow this with another document if the IETF could agree how to fix these things.
I'm afraid that, you'll go through this effort, you'll publish the document, and that'll be the end of it. It will, never be read and never be acted upon. So, sad.
Tom Herbert. So I kind of have a similar point. So the document is really good at describing the impact, but that assumes that the part of the impact is not that people will adapt to it. So, and I said this before, I think it's a one-way ticket that encryption of transport headers is coming. Clearly, Quick has gone that way. The privacy and the anti-ossification arguments are too strong. So when I read this document, I'm reading this in the light of, okay, we have a problem. Now the next question is, how are we going to adapt the world to solve this? And I think it might be helpful to describe more what exactly is the information that is needed that would not be present anymore with the encryption of the transport header, and then what are the alternatives to get that information? So I think I said before, for instance, we do have extension headers. They could, you could put transport layer related information into extension headers, and that would allow the exposure of this information. So if we can define the information that's needed, we could develop standard ways to overcome this loss of information.
I think we could. I think that when we started this was an extremely contentious document to start working on, to try and say that, by the way, people regard privacy as important, they regard encryption as important, Quick is important, but operators are unhappy about some aspects of this with respect to what they currently do. Now, even without going further, that I believe that is a useful thing to document. It doesn't solve the problems, and the unhappiness will change as people understand more. I'm a little bit frightened to try and dig further in the next step. I think it probably requires a new document and a new start. I mean, to get those recommendations out. Yes, I agree with you, by the way, extension headers are cool. I think we say that extension headers are cool where they work.
So one quick additional comment. So I think in the draft, the parts where this exposure is required for protocol development, I'm not entirely convinced of that. We've done a lot of stuff, for instance, at Google with TCP. Quick was developed without any ability to look at it on the network. So clearly you can do serious protocol development without being in the network, at least for that part.
Right, okay, but can we do it with the congestion control things that we normally do here? Because with BBR, we were effectively tagging packets on in the router queues to find out how they were behaving.
Yes,
which is why things are slightly changing.
Think of it this way. I'm Google, I'm deploying to the whole world. I don't want to have insight to every network because it's just a mass jumble of information. It's very rare that we'd have to go into a particular network to see what's happening. We can get immense amounts of data at the endpoints, and that, to a large extent, that's valuable enough to deploy major protocol features.
Spencer Dawkins says the soon-to-be former area director for this draft. This is a conversation that Corey and I had early in the -00-01 stage, where basically we did not see any. I think you just said this, but I did not see any way forward to do anything that was not the most bland form of description. And basically there were people working in this space that didn't have a description done by experts in transport to work from. So, they were saying, well, people do this, whatever this is, and stir chicken entrails, and maybe they know things. And that was the level that was the quality of conversation that we were having. And that was resulting in nice long IETF last calls and nice long ISG evaluations. And if you look at it wasn't just the IETF, the IAB workshop on the Marnu workshop report. I ended up taking that over and editing it. It took two and a half years for it to come out. So that was the target I was encouraging Corey to work towards. I hope people do everything that somebody got up here and said that we should do. I hope they don't do it in this document. I think this document by itself is going to be a useful thing to point to for all the people that want to do the things that people in the line got up and suggested. But that's what I was thinking. And soon you'll be able to blame me.
Okay. So we'd still like to ask the chairs if we can do a working group last call on this.
I would think that would be a good thing to do. Chairs need to put their heads together to figure out how many working group last calls we're doing to which docs in which order between now and Montreal. But yes.
Okay, I can put my head back on the table. Yes, that's good. Okay. So, Bob, do you want to come and talk about the L4S work and give us an update on these documents? Slides are not up to date.
They weren't a few seconds ago.
Okay, well then that is an issue.
Hi, Bob Briscoe. I guess I can start introducing myself and stuff. This is about low latency, low loss, scalable throughput, or L4S. There are 3 drafts on this. There's the L4S architecture, which I'm not really going to talk about today. There's and then there's essentially one for a network node, dual queue, coupled AQM, and I'm going to explain today how that could also be a flow queue system, and the other for the host, the sender. Well, actually, the other is more for the interaction between the host and the network. It's the protocol, it's the code point, and what the conditions are for both the network and the host to use that code point. Are we getting anywhere?
I got a second version of this. Let's see, this is the one you want. Which slide do you need to look at to figure out which slide?
Oh, it's the IPR slide, which is it may be worth just carrying on with it as it is, because the whole point was not to draw attention to it.
Oh, okay. Well, in any case, this is the second version of the slides.
Okay.
So with luck, they're what you're expecting, and we'll
Okay, we'll try this. Sorry.
A little bit of game plan on time. 10 minutes or less for presentation, and then we will allow some additional slack time, which we do have on the agenda for question and discussion. So the goal is to get through a brief presentation, and then any questions and discussion can start from there. And we have some time to allow it to run, and we're going to do the same for the sun congestion experience presentation.
Okay. Okay, so a quick recap on what L4S is. Extremely low queuing delay is the motivation, and for all internet traffic, that includes link saturating, capacity seeking traffic like TCP, not just the odd game packet and DNS and things like that. And it's about 1 or sometimes 2 orders of magnitude better than the state of the art, and you'll see that on the next slide. Getting about 100 to 200 microseconds median queuing delay, even under heavy load, which is pretty cool for maybe a 10 millisecond internet path. This is internet paths, not data centers. Getting in queuing delay in the microseconds, hundreds of microseconds, as opposed to the 5 or 15 of FQ log pi. And the intent of that is to enable all the new applications that have been sort of arm-waved about for years, the VR, the controlling nuclear power stations, or whatever you want to do over the internet these days, remote surgery and all that. And so, augmented reality, et cetera, et cetera. The architecture is shown there, essentially a different source behavior and a second queue in the network, or at least a second queue, certainly an isolated queue for the low latency traffic. The lower orange queue is not intended to be a sort of lower priority queue. It's intended to be for old stuff. It's the legacy transport protocols go in there, and it would be the same with a multi-queue system, a FQ system. Some queues would be for the old traffic and some would be for the new. And the sort of key invention here was really to find a way to do this, get such low latencies in what is effectively a FIFO queue. If you put all your traffic in that top L4S queue, you can still get those low latencies. And in fact, that's what this slide shows. Just give you a quick guide to how to read a graph, or graph, depending on which. This is queuing delay along the bottom, and the percentiles in log scale, up, down the vertical, in fact. It's a complementary cumulative distribution function, if you want. And so 5 nines, or let's make it a bit easier. The 99th percentile in the middle there somewhere means that 99% of packets have queuing delay lower than that. And you'll see pi with ECN and without, FQ with ECN and without, and then dual pi 2, which is the L4S architecture with ECN and without. The red ones without, which is then in this classic queue. The blue one is with, and that's where you're getting your 100 or 200 microsecond median delay. 1 to 2 millisecond 99th percentile. But the impressive thing about this is the traffic model, which I'll put in tiny letters just because it's not really for presentation, but you can go and read it if you want. There are 300 web flows per second hammering this over a 10 millisecond round trip time, all different file sizes, and we're still getting below 1, and full utilization as well, I should say. And we're getting below 200 microsecond median delay and below 2 milliseconds otherwise. So essentially this means you can put all your traffic in this queue as long as your TCP supports it, and the L4S TCP we've been building is this thing called TCP Prague or Quick Prague, and so on. Right, so at any percentile we're getting about 10 times lower delay than the current state of the art, and that's, it's not a pissing contest. We're not saying It's because it's a better AQM. It's because we're using a new congestion control as well with it. It's the interaction between the network and the end system. Which is causing the thing.
Okay, Bob, keep moving. You're about
Yep.
5 minutes into your 10.
Yep. Okay. So this is a cut from a paste from the landing page with all the code on it. So as you've heard, got all these different pieces now all implemented in various stages of development. That none of them are absolutely cool and finished, but all working on it. And then the component parts, accurate ECN, and so on. Thanks to Olivier. And the big lump in the middle there is the next slide, which is that since the last IETF, low latency DOCSIS 3.1 has been announced. The specs were released in January, and it is now mandatory to have low latency DOCSIS, which is a section of the DOCSIS spec, DOCSIS 3.1 spec, for both cable modem in the upstream and CMTS in the downstream. And so it's mandatory to support L4S, and it's also mandatory to do a number of improvements in the MAC layer to improve the request grant loop, which deals with those two main causes of delay in that plot and gets them down under a millisecond. There's a white paper on it as well. Those orange things are all hyperlinks in the slides, and certification test plans are nearing completion, and implementation is in progress. So anyone interested, come and see me afterwards, and we can talk about trials and all the rest of it. And applications to run over it and stuff. And I should add that Cable Labs, obviously, the working group that's been working on this is with all the vendors around the world, all the cable operators around the world. So, it's not just US, it's not just any particular country, it's everywhere. Right, moving on to what we're doing in the IETF with L4S. Thank you to all these people for their reviews. It's a bit of an awkward slide because obviously reviews, you don't know whether people support you or not. So when I put non-supportive there, that doesn't mean to say all the rest of them support it. They're just giving comments, but those that specifically said they didn't support it are there. And some people I'm just trying to find out more information. So Michael, do you want to drop it?
Just add me there, send an email to the list, and you can put me to the non-supportive. Thanks.
Okay. Right. Okay. So there've been full reviews from Nicola Kuhn, Gori Twice, and Richard. And as I say, I'm not necessarily saying Gori supports this, and he's just reviewed it in full, or any of those people. And more focused reviews from Michael, Ingemar, Praveen, and David. Ingemar mainly on the effect on real-time transports, Praveen on TCP, David on the sort of rack requirements. Then we've had reviews from the slides going up and down.
We're trying to move you along. You have 3 minutes left.
Right. Okay, so the technical issues. Drop detection, we've had to fix some bugs in Linux DC TCP, done that. The main outstanding technical issue that's been raised, particularly by Jonathan Morton, is the ability to detect classic ECN, a classic ECN bottleneck. Now, we didn't put this as a high priority. People obviously, or some people want us to put it as a higher priority, and we've accepted that. We're trying to dig into why Apple's study found so much CE in certain countries, Argentina and France particularly for some reason. That found that 30% of Apple devices saw at least one CE in 12 hours over a 6-day period, I think. And Padma from Apple is helping to dig into that. They're still gathering that sort of data all the time, but it takes a while to sort it all out. But at the same time, the studies that have been going on, every few years, Brian Trammell did another one in January and found nothing again, just 13 CE. So I think it does pay to be looking more at everything like Apple is. And we want to understand somehow whether these the deployment of ECN in the internet is in FQ systems, in which case it doesn't matter. Come on, I need to be able to say something sensible. Please don't keep moving it around. And I'm serious, right? Okay, this is the criticism, and I'm trying to deal with it, right? Put me off the track now. Yeah. So if those classic ECN bottlenecks on the internet that are giving out these CEs are in FQ systems, which is what we assumed, then there's no problem because we're talking about safety from other flows inside an FQ system. So the FQ scheduler deals with that. If someone started turning on old Cisco routers with with ECN in those, then it is a problem and we need to deal with it. And so we worked out a way to see if we can measure which sort of things they are offline, not sorry, online. And we're having to deal with that. I'm going to skip over this one. These were all misconceptions. Oh no, the middle one, I think just to point out that an FQ system is a very easy thing to make it support L4S. So we hardly ever talked about it because it was just so easy. And some people have got the impression that that means it's not going to support L4S. Well, it's just we didn't bother saying much about it because it was so obvious. And I'll have to fix that in the next version of the draft.
On that one, it's probably useful to update the draft to have a separate section that just calls out that you can do it this other way.
Yeah, that's what it says there. Intellectual property. There is an IPR declaration on this from Nokia on the dual queue coupled AQM with FRAND terms. There's a GPLv2 license on the Linux implementation of this, which of the same thing with Nokia people on it. And so that's all I'm allowed to say. Just stating facts.
Maybe we can interject to stop you, to let you talk after we've talked. But on that one, I think the chairs would be interested in finding out more about the IPR and whether the drafts are able to be implemented without that IPR.
Right. Okay.
That's an observation, and we will be continuing that. If you have opinions on this, please come to the mic or please talk to the chairs.
And there has been some discussion on the list, and obviously the discussion I've just been having about FQ being an alternative and so on, and the fact that there's GPLv2 on the Linux code is another way to get around it. Sorry, that's my personal comment, not on behalf of all the authors. Right.
Okay, next slide.
This is the last slide. So we've got to deal with that classic ECN bottleneck case and some minor text updates to all three drafts. And once that's all satisfactorily resolved, I'm hoping we can go for working group last call on the three of them. And then, well, the experiment is already starting. We've been fairly careful about releasing the code because obviously we're using ECT1 on the internet, this last unicorn. So you have to manually configure it to be on. It's nothing's by default, so hopefully it will not stay on for years if this experiment doesn't work or whatever. Right.
Can we take questions? While people are thinking, I'd like a show of hands for people who've read the current version or a recent version of the ID and architecture drafts. Have you read both of these? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14.
Yeah, I see
15
dozen hands. Good.
Yep. Has anybody read the dual queue internet draft recently? Slightly smaller, which is what I thought. Okay, questions, please.
Michael Abrams. So you said about the implementation and running code. So is this Linux code or where is that and what's the status?
Right. When you go to that page, that URL at the top, there's dual queue coupled AQM for Linux only at the moment. That's the GPLv2 code. The Curvy Red implementation is not public yet. That's in hardware for high-speed switches. and I'm not allowed to say who it is yet because they want to announce it when they do it. TCP Prague is Linux only at the moment. Quick Prague is for any operating system, but not being tested on anything but Linux yet. And Scream is, I think, also for any operating system.
But okay, so are these patch sets against the Linux kernel for like the most recent?
They're all the things I said about Linux were they're against the most recent kernel, and we're putting those patches onto the NetDev list. We would have put them on, except that the guy who, ironically, who had to do that, couldn't get access to his email because of the VPN. We couldn't get access to an email server that formatted things in the right way for that list. You know what I mean?
No, I know the problem.
Yeah.
Okay. Another question. I've seen in some of the drafts, I'm reading there's a NQB. No?
Yes. No, non-queue building.
Yes.
Yeah.
So there is a flow classifier there. The draft hand waves around per flow traffic statistics and so on. I thought this did not have a per flow, didn't need it.
No, it's not there's queue protection in there that is per flow in the DOCSIS system for operators that want it to be able to kick out individual flows that are causing more queuing than other flows.
Right. So it says something about queuing behavior analysis. This mechanism would utilize real-time per flow traffic statistics to identify whether flow is sending traffic at a rate that exceeds blah blah blah.
Yeah.
So this is not needed, but you could do it, or
yes. Yeah. And I did intend to put a draft in on that to basically copy it out of the DOCSIS spec. The DOCSIS spec, you can go and look at it, but just to make it into an internet draft, essentially translate it into ASCII for people who can't read Times Roman or anything like that.
Okay. So is that in the running code as well? So you can test?
No, not at the moment, but I don't see any obstacles to doing that, but I haven't gone for that approval yet. But
right. Do you think that will be done in the hardware kind of implementations for modems and CMTSs and so on?
Okay, so the modem implementations, they're all going to be software upgradable, field upgradable. So this is all going to be done in software on top of the existing 3.1 modem hardware. And the software for that queue protection has already, an NS3 implementation has been done to simulate it, and it's now being implemented for the particular hardware platforms. That's the Intel and Broadcom ones.
Bob, so while we're getting to the next question, could you quickly summarize the note you sent to the list about PI2, Curvy Red, and the patent?
Right. This will have to be me individually, not as on behalf of the co-authors.
That's you individually. That will have to do because messages are sent as individuals. That seemed to be an important message that bears on how we think about that patent with respect to what you've done here.
Yeah. So this starts to get conjectural because there's actually 3 IPR declarations, and one of the earliest one is very general. So, I believe there's prior art on most of the things, and so but beliefs aren't important in IPR. So I'm not going to say much more about that. Then there are 2 other declarations, one of which is about a particular scheduler called the time-shifted FIFO, which you don't have to use, and in fact we don't recommend it, so I'm not too worried about that RPR declaration. And the final one is about the dual queue coupled AQM, and all the claims in that, as far as I can tell, and as far as Alex, who posted the note on the list, could tell, require the dual pi squared AQM, and the whole idea of the dual queue AQM coupled AQM internet draft is that it's a general framework for slotting AQMs into it, not just the dual pi squared one. So that third patent seems to be only about dual pi squared as an AQM inside that framework, but you could put other ones in. And the second appendix in that draft is about using red and Kirby red as the 2 AQMs as another way to do it. And I believe, no, I'm not going to say there's no IPR on those things because you can never prove a negative, but you know, I'm not aware of any, and we certainly didn't put any in.
Let me quick pin you down on one point, which is that as a key author of that draft, you believe that Kirby Red is a good and fine way to good and fine AQM to use in a dual QA AQM implementation.
Yeah, I mean, I will say that we stopped doing it because we were getting better results from the dual pi squared one, but I don't know how far we'd have got with pushing harder on the you know, the Kirby Red one. And Kirby Red is the one that's being used in the high-speed switches area. So, yeah, I can't really answer that question because we haven't fully tested it because we never continued down that direction. But yeah.
Yeah, you have your
Rod Grimes with FreeBSD Project. I just have a question about, are all of the pieces to implement L4S documented in RFC draft? Because it sounds like there's some pieces that are coming outside from DOCSIS.
Right. The only piece
hardware
that
vendors.
The only piece that isn't is this queue protection function that we just talked about as optional. And we intend to put that into an internet draft. It's just with all this blowing up recently, I didn't get it to the draft deadline. But it's, you know, the DOCSIS spec with it in is openly available. The links were on these slides.
Yeah. Thank you.
Yeah. In pseudocode, that is, not the code. Yeah. Oh, and the other thing is, Tom Henderson is pushing as hard as he can to get the NS3 implementation of that queue protection function and the dual queue AQM for DOCSIS all released. And there's a DOCSIS model underneath it, which may take a bit longer to bring out, but the whole intention is to bring it all out. But the trouble is we're sort of working on it at the same time as trying to publish it, and you sort of want to get on with making it right before you publish it and so on, you know, so it's.
Okay. Yeah. One more question from up here. How close is the TCP prog implementation, or quick prog for that matter, to satisfying the rack-like requirement that's been the cause of all this excitement over at least a couple of IETF cycles?
Right. I believe if you use pacing in your initial round trip, I believe it satisfies the requirement.
I'm asking about running code.
Yeah, that's what I mean. Yeah,
okay.
Yeah. I mean, it depends how you configure it, but yeah.
Okay, so right. Anybody got more questions? My question to Bob is, do you think now it might be an appropriate time to arrange an early review from the people who come to the IETF who might need to read this, who don't come to transport? In other words, can we send it to maybe interior review team to get some feedback on whether the interior has problems with the ID and architecture drafts?
That would be a very good idea, yeah.
Please tell us when you've applied the edits and you're in a position to do
that,
so. Other people, please comment on the list because we now have a chance to change these documents and refine them, but we are going to try and solicit some wider review.
Okay. I think it's time to experience some congestion. Let me go find the slides.
Waiting to say that.
We need a moment of levity after some of that discussion. Okay, and if I've done this right, the clicker's going to work for you. Yeah, that looks good. Okay. So I'd point out that Jonathan is is not only a speaker, he's also wearing a newcomer ribbon, which is truly impressive.
Yes, you did tell me that. Okay, so hi, I'm Jonathan Morton. I'm the principal architect of Cake, which is a packet scheduler that was upstreamed into Linux last year. And today I'd like to talk about some congestion experienced, SCE, which uses the last ECN code point. And in that respect, it is a competitor in some ways.
Can you speak closer to the mic?
Yeah. So,
Yeah,
does that work better? Okay. So you all know the classic Reno sawtooth. It quickly drops out and slowly grows back. Cubic does that more cleverly, but it basically does the same thing. And what you see is oscillation. And because it's oscillating, even if the average is correct for the native bandwidth delay product of the path, it will sometimes be too high a congestion window, too high a send rate, and it will build the bottleneck queue and have high delay. And sometimes it will be too small a congestion window, and it won't get enough throughput to fill the capacity. And that's because the network doesn't give them enough information. We have a binary signal once per RTT, and it's like your refrigerator. It will go above and below, and oscillation is pretty much guaranteed. As a result, you have both underutilized and too much delay because there's not enough information. As a solution to this, we are making use of the fact that nonce sum was deprecated a while ago. It was moved to historic status, and because it was never really deployed. So we have the ECT1 code point that we can experiment with, and also the NS bit and the TCP header, which I won't talk about, but it is there. And this is popularly known, ECT1 is popularly known as the last bit of the IP header. And this is important. In fact, it's really the last half bit because it is the last of 4 code points in a 2-bit field. And one projected use of this code point is as an indication of less severe congestion. SCE, some congestion experienced, is precisely that. And our aim is to maximize incremental deployability. Through backwards compatibility, keep things as simple as possible. SCE itself is ignored safely by existing ECN-capable transport flows. SCE-aware middle boxes will still signal congestion experienced, as at present. SCE-aware flows will respond normally to congestion experience marks by existing middle boxes. The meanings of ECT0, not ECT, and CE remain stable with their current meaning, current semantics. And that's key to backwards compatibility and incrementable deployability. We have 2 congestion signals. SCE means that there is detectable congestion. We have something in the queue, but maybe less than justifies setting us congestion experienced mark, because setting congestion experienced gives us a big drop in the congestion window, which is too much. SCE is not a binary signal, but a stochastic one. This conveys more information. Independent of round-trip time cycles, the send rate should evolve smoothly to an ideal value with minimum delay and maximum goodput. We have some stuff behind the scenes as to how transports should respond in order to converge to fairness. Some of this uses existing research from other places, and we have our own ideas. We want to verify this stuff by experiment before officially drafting it. Work is already in progress on that front. Now, if there's a big change in path capacity, a CE mark will automatically give a stronger signal for a faster response. and CE is produced by SCE-aware middle boxes as well as SCE. CE is also the only signal besides stop emitted by existing AQMs, and existing TCPs will ignore SCE and react as usual to CE. This is all part of the backwards compatibility. We have a state diagram for what we're allowed to do with this ECN field. It's a very simple 2-bit field. Not ECT always has to stay not ECT. RFC 3168 defined how the ECN field could be changed by middle boxes, allowing either ECT0 or ECT1, which becomes SCE, to be changed to CE. With SCE, it is also permitted to take this extra diagonal path from ECT0 to ECT1, from ECT to SCE. But to preserve congestion information, it must be required not to allow movement in the opposite direction from CE to SCE to ECT, as that would erase congestion information. Now, we are developing diagnostic tools to help develop the experiments using SCE, and here is the output from one of these. This is a 100 packet windowed average traffic proportion versus time, from just a few seconds at the beginning of a flow. So this is very early results. And the yellow trace is SCE marking, and you can see clearly that this comes in before the red CE marks. And the SCE proportion goes down as the sender responds to the CE, and the ECE trace in blue. And then shortly thereafter, it goes back up again, and then the sender responds to CE and it goes back down. And this is a sender that is not SCE aware. We haven't got that far yet. But you can see that the SCE marking is working. We have patches to TCP trace in progress as well, and also to Kathy Nichols' excellent tools. As evident from the previous slide, we have some running code. This is very simple middle box code. It's two slightly modified CODEL type AQMs in Linux. One uses a step function, the other a ramp function. SCE marks are emitted successfully, and they survive across real internet paths. This was not very difficult to test. Work is ongoing to refine the system level behavior, hence experiment 3, checking our maths. And we currently believe we can achieve round-trip time fair convergence using a single queue AQM. So this has implications for high capacity links in the faster parts of the internet, where legacy hardware or even the difficulty of implementing multi-queue AQMs becomes important. We also have work underway to hack together a demonstration transport protocol for real-world verification of the system behavior. And we will keep more details on our website at bufferbloat.net.
Would you say a little bit more about what you meant by check our maths for experiment number 3?
Basically, we have some internal proposals for how to make the TCP sender react to SCE markings. One of these proposals is actually to reuse some work from DCTCP. This is pretty likely to work because of DC-TCP. We also have a different proposal involving a modified Reno linear algorithm, which decreases by 1 segment for each square root of segments in the current congestion window. So probably both of these are capable of converging to RTT fairness, as the AIMD system presently does. But we need to verify this to be certain.
So this is what, so a simulator experiment to figure out what the entire congestion control feedback loop looks like before you tackle, or in parallel with experiment number 4 that tackles details of how to make it work with the transport protocol?
Basically, yes.
Okay, thanks. Check our maths might have been, oh, we're going to write a theory paper. I was trying to figure out how that lined up in the experiment. Now I understand. Thank you.
Thank you for the question. Does anyone else have any questions?
Hi, Brian Trammell. How long do you think this is going to take?
That's a good question. It really depends on how many people we can, with the right skills and interests, that we can get involved in this. At the moment, it's just me and a couple of other people.
All right. So,
but we are making reasonably rapid progress since we only started really hard work on this a few weeks ago.
okay. So order months, not decades.
Yeah.
Okay.
So a quick chair question. Are you intending to update the internet draft that you submitted? And what timescale will we expect for the next revision?
I think within the next couple of weeks, we should see some sort of update. We have done some work since the 00 was submitted.
So thanks for submitting the 00 before the deadline. That was appreciated.
Also, I'm going to exercise chair's privilege to quickly jump in ahead of Jake with one thing I want to make sure we're clear and clarification. Could you go back one slide here? Okay. What I think I'm looking at is we have a flow here whose sender reacts according to RFC 3168, running into a box that is marking both SCE and CE, so that the output is a mixture of SCE and CE marks, and there's enough CE marks being applied to get the 3168 sender to respond the way it's supposed to. Is that correct?
That's correct. In fact, the CE marks are identical to a conventional AQM.
Hi, Jake Holland. I wanted to ask another document question about. I believe the SCE draft had a bit of a hand-wavy proposal about doing it from the receiver side with RWind, and I think there's been a little bit of discussion on the list about doing a feedback mechanism that's either similar to ACC, CN, or either option-based or a few other ideas. Could you speak to how do you see the separate proposals and the separability of different proposals in the upcoming documents? Like, would you integrate one with SCE, or would you have a separate document about how to do the feedback, or what are the plans?
At the moment, I intend to have one document describing SCE itself, as in these slides, and others describing its application to particular AQMs and particular transport protocols. So we put forward the receiver side implementation because it had the least number of changes on the wire.
Yeah, that makes sense.
It's not necessarily the best performing solution. We've also come up with, since then, something using the NS bit to feed back this information, which is a nice symmetry with the reuse of ECT1 from non-sum, I think. It would also be possible to use a TCP option, including, well, at least in theory, ACK-ECN would work as is.
Great, thank you.
Hi. I've got two questions. The first one I might as well, as it's
Okay,
on this
for those-
slide. This is Bob Briscoe. Yep. Independent in this context. I'm independent in the context of end-to-end stuff, and I'm Cable Labs in the context of network stuff. Right? So.
Okay.
Yep. The CE markings. I think when you get this going with an end system, I mean, I understand why you have the two, because for the backward compatibility for a classic ECN and a 3168 ECN router or network box. But once you're got an end system congestion control that recognizes the SCE markings, I think it's very unlikely you're going to get both at the same time. I mean, as you saw in the percentile plot I showed, second slide or so, the threshold, the lower threshold level, the shallow threshold, tends to be a ceiling for where your congestion control gets to. And so if you're getting some CE marks as well, that means your percentile of queuing delay is also going right up into the queue, and we just don't find that. So the idea is on having a mixed signal and being able to get more information out that way. Might happen for slow start or something like that, but you essentially don't want to have that happening if you want a low delay congestion control anyway. You want to stay. You don't want to go and get the CE signal, because then that means you've effectively failed because you got too far into the queue.
Is there a question there somewhere, Bob?
Okay, that was a point, I suppose. The question is regarding the behavior of tunnels with the SCE marking, and I had prepared a slide that's at the end of my slide set in a spare slide to explain this. I don't know whether you can jump back to that. Essentially, up until not that long ago, 2010-ish, because the original ECN spec didn't have this extra transition, all the tunneling specs for ECN did not allow for the fact that if you're marking or changing ECT0 to ECT1 inside on the outer of a tunnel, when it gets to the end, it will just change it back to 0 again. So these graphs here come from the time when I got that tunnel mechanism changed, which benefits you, but I'm pretty sure you'll find a large number of tunnels on the internet do not do this. So the difference is the before and after in those two. You'll see the different one there is when you've got a 0 in the inner and a 1 in the outer at the decapsulator, it will turn it back to 0.
Yeah. I think I see what you're saying.
Yeah.
So you're saying that the SCE information can be erased.
Yeah.
Well, in that case, you simply end up reverting to, shall we say, classic ECN behavior, and this is safe.
Yeah. Oh, yeah. It's safe. Yeah. It's that the number of places where there are tunnels on the internet is probably greater than the number where there aren't.
I also want to gently emphasize the third bullet on Bob's slide, which is that this is misbehavior of deployed code that is pre-RFC 6040, One of the things that us transport reviewers are trying to impress on those who do tunnels is RFC 6040 is how you're supposed to do EC and decap, period.
Yeah, but that draft or that RFC deliberately didn't make prior implementations non-compliant. You know, they have to still exist. They don't suddenly not exist as soon as you introduce a new RFC.
Well, yeah, this is something that SCE can survive. You know, as a system. I mean, even though the SCE information is abased, the endpoints will still behave themselves.
Yeah, but things like ISPs that use L2TP, which a large number do, and then you've got all the Teredo, all the other possible tunnels. All these tunnel endpoints probably are going to just erase what you're doing. So, you know, that's one of the.
I suspect there'll be a number of these things to check through as the document matures, and we'll just have to look at them. Please look at the draft, and please look at the next version, which will probably be enough time to actually provide some of the details you've talked about here.
Right. And the crucial thing I think I heard there was if in the worst possible case, it all still falls down to the CE marks, getting something useful done, even if it's not the ideal thing you wanted. Thank you very much. Okay, Greg White presenting remotely. How do we make this happen?
Hello, can you hear me?
Oh, yeah. Hi.
All right, let's go get his slides.
All right.
Whoa.
Hopefully you can both hear me and see me.
I have no idea how to turn. Does someone know how to turn the volume down in the room here? All righty.
All right.
Hi, Greg. Your slides are up.
Okay, thank you. So this is a slide deck to present an update on an individual draft that I submitted several months back on a proposed new district code point to identify non-queue building traffic. You can go ahead to the next slide.
Okay. Next slide, Michelle.
Thank you. So the goal of this new code point is to enable both low latency and low loss for sparse traffic flows. And I'll just jump down to the first use case for a moment. The use case that motivated this development is in a dual queue L4S link, where you've got a low latency queue as well as the classic queue. We'd like to be able to identify non-congestion controlled flows that can safely coexist with the L4S traffic in that low latency queue. And there are an awful lot of flows that could very likely coexist very nicely with congestion controlled L4S traffic and could get the benefit of ultra low queuing delay. And so there may also be some other use cases that could make use of this code point. There's currently a draft that illustrates potential use on LTE or 5G links. And I've exchanged an email with the author of that draft to work on coordinating progress on this code point. Also, potentially in an FQ-CODL link, there could be value in having a sender mark its packets as non-queue building. FQ-CODL, as I think most folks probably know, already has a mechanism to identify sparse flows and give them a priority treatment in the scheduler at DQ time. But potentially marked NQB marked flows could be given slightly different treatment in an FQ system, potentially disabling the CODL packet drops to allow those non-congestion control flows to not experience CODL-induced packet drop. Now I'll just go back to the goals again. I mentioned the first one. The other two, goal here is that this code point is not conveying a value judgment or an expression of relative importance of the traffic relative to other traffic on the network. It's intended to describe a verifiable behavior of the traffic. And so as a result of that, the intention is that there would not be an incentive for applications to mismark their traffic. All right, can go on to the next slide, thank you. So the use case, Bob Briscoe already mentioned that we are supporting L4S in DOCSIS 3.1. In the box on the lower right, there's the link again to the informational draft that we submitted that describes the use of L4S in DOCSIS, and also a pointer there to the queue protection algorithm. So the diagram at the upper right shows the functionality here. You have a set of classifiers that map incoming packets into either the low latency queue or the classic queue. In DOCSIS 3.1, we're looking at either the diffs code point being this NQB value, or the packets are marked with ECN with ECT1 value or CE, and that would direct a packet towards the low latency queue. All of the packets that flow through that or are destined for the low latency queue flow through a queue protection algorithm, which there's been a little bit of discussion on that on the list, as well as has been mentioned previously in this session. And the goal of that algorithm is to track the latency of the low latency queue. If there is a queue that starts to form there, to identify the flow or flows that are causing that, and to redirect the packets from those flows to the classic queue. I'm not intending to go into the details of the algorithm in this presentation, but again, you can read the details in the link on the lower right. Okay, next slide. So the definition of a non-queue building flow. So the idea here is that again, this is a non-congestion controlled flow. And by marking itself as NQB, it is claiming that it will not cause a queue in the network. In other words, it's sending at a relatively low peak data rate, such that it expects that it's going to remain below the available capacity in the path. Obviously, a sender can't know that for sure in general, although there are a lot of applications that already attempt to do this, right? If they're non-congestion controlled and low data rate flows, they send at a rate that their expectation is that they're not exceeding the capacity of the link. Nonetheless, if such a flow does cause queue buildup, the expectations for the source should be that it may suffer some consequences in that case. So in the L4S case with queue protection, the mismarked packets, or packets that were marked non-queue building but are causing the queue to form, would get reclassified to the classic queue. And as a result, they may see higher latency. They may arrive out of order from some of the other packets in that flow that may have gone on the low latency queue. In the case of LTE or 5G, this is a suggestion, I guess, that such mismarked packets in that case may see higher loss. Question mark there, because that is not an aspect that's been discussed in detail in the LOLA draft, but we would work on integrating the right treatment for that scenario as well. And then finally, in FQCODL, supposing that the implementation FQCODL does disable CODL packet drops for NQB flows due to the fact that they're not congestion controlled, the ramification there, if a packet was mismarked or a flow was mismarked, would be that that flow would see its own queue delay, the queue delay that it's causing in its queue. All right, next slide. And then for the NQB definition, this is reflecting what's in the current draft with one delta. But first off, I'll say this is not intended to be a guaranteed service. Again, the sender won't have knowledge of the available capacity in the path, and so it's again taking its chances to some degree and marking itself as NQB and getting the benefits where it can, and lower data rate flows that are marked as NQB would likely have a greater chance of achieving ultra low queuing delay in more network conditions. So the three requirements listed here, that a node supporting the NQB per hop behavior must queue the non-queue building traffic separately from the queue building traffic. The second one is not currently in the draft, but would say this queue, this NQB queue, should disable the AQM-induced packet drops for the NQB marked packets. And then the third requirement, this queue should support a latency-based queue protection mechanism that is able to identify queue building behavior in flows that are classified into the NQB queue and to redirect flows causing queue buildup to a queue building queue. Again, that's an example. It's provided in a DOCSIS specification for one algorithm that could be used for that purpose. This may not be necessary in FQ-CODL nodes, since every flow should have its own queue in that case, and so no redirection would be needed. All right, next slide.
Greg, quick comment on that last major item. There's a good chance that will have to be a must to thwart attempts to use this for theft of service.
Yeah, I agree that that could be promoted to a must. I think in a lot of nodes that would be a requirement by the operator that's running the node, whether it's the end user or an ISP. Like it could be promoted to a must.
David, this is Bob. I would have thought it's a policy, so you don't want to tell an operator they must do something that's a policy.
We should talk more about this later.
Bob, you've confused support and use. As a support requirement, it's going to have to be a must. Then your policy rationale is completely correct.
Chris, to join.
Chris Seal, Hutchison. Just going back a slide, why the assertion that it would be an LTE and 5G that you'd see higher loss?
So in the LOLA draft, that is the stated assumption that that if a flow is marking its packets as NQB but is bursting at a higher rate than the link can support, that the ramifications of that would be higher loss for that flow. That's something I think that could be debated with the authors of that draft, whether that's the right treatment for flows that are say mismarked as NQB.
So I mean, it's which property of those is it that you see as the issue? Is it the burstiness or high jitter or what? I'm unclear what they have that's distinguished from another type of network.
In the LOLA draft, they wanted to find a penalty for building a queue. And the penalty, I guess, that Greg identified is it could be higher loss. It could also be the latter one. It could just build its own queue and therefore suffer greater delay because it's done it this way.
Okay, thank you.
My guess is that and the other things here will actually require a bit of work as we go forward. If we decide to do this work, this is something interesting to figure out how all these things fit in different environments. Greg, I'm going to go back to the slide you were on.
Okay. All right. Yeah. So the proposal here is to assign a particular code point that's currently unassigned. The value hex 2A or decimal 42. This is currently unassigned in the diffserv code point pool 1 that's set aside for standards action. And the reason we're suggesting that this would be a particularly good code point for this purpose is that it is very similar to the EF code point. There's only 1 bit difference between the two. And there may be some implementations or some network environments where both EF mark traffic and NQB traffic could share a queue. And so that would be done very simply with this code point. Also, many Wi-Fi APs commonly map diffserv code points into WMM access categories using the first 3 bits of the diffserv code point. A little table on the lower right that shows some common defaults in Wi-Fi. And so this choice of this code point would, again, align it with EF, expedited forwarding, as well as voice admit and CS5 in going in the video access category, which is a lower latency media access on Wi-Fi as well.
Okay, Greg, I've got a to-do. This is David again. I have a to-do item for you. Next version of this draft. Please read RFC 8325 and write up how this interacts with what was done there on diffserv to UP mapping. You'll want a normative reference to 8325, and let's not go down that rat hole now. But it does make changes to those defaults.
Yeah, I'm aware of that RFC. Yeah, thank you.
This may be addressed by the chair's comment just now, but I'd just like to ask about an NQP is not supposed to be a priority mechanism, but this mapping to video does give it priority on Wi-Fi. Is that a concern?
So Wi-Fi scheduling is, for better or worse, only defined in terms of these 4 access categories commonly. There are extensions for additional quality of service mechanisms that my understanding is are not widely implemented, if at all. And so this is kind of a way that this mechanism would fit into existing Wi-Fi quality of service mechanisms, WMM. It wasn't the goal really of the definition that NQB exactly aligns with the way scheduling is done in Wi-Fi APs and Wi-Fi stations, but it's kind of a useful byproduct, I think, of that.
Fair enough. Again, another one we'll have to pick up with as we move forward, I think.
Michael Abramson, just to confirm I get my bits right. So this is old precedence 5. This is next EF.
I don't think we should bash the code point. I think we should tell Greg, if you propose any code point here, it's going to have to be bashed by people from various perspectives, not just the lower layer mapping.
So we're having that discussion later.
We should keep that one to later. We will find a diffserv code point that works for you, Greg. And thank you for the offer of this one to start from.
Right, and this earlier, a crucial thing that will help a lot here is let's get the 8325 Wi-Fi stuff into this draft as well as the defaults. Among the reasons for doing this is 8325 has some rather critical things to say about those defaults.
Right.
Okay.
Okay, the updates for this draft. So the original draft was submitted as an informational draft, and I promoted this version to standards track and added the requirement statements that were listed on the previous slide, as well as writing it as a proposal. And then there was a fair amount of new text added into the comparison to existing approaches section. I updated the discussion on FQ Coddle as a result of the comments on the list. I also added a discussion of a couple of other existing approaches that I was made aware of. The heavy hitter filter in Linux is one, and the dynamic packet prioritization mechanism that Cisco supports on some of their switches. Mentioned both of those. Then I added the IANA considerations and security considerations sections.
Okay, last question.
Quick question. This is Paul Congdon. In your discussion about Cisco heavy hitter and Cisco DPP, you're commenting about their method in which they're identifying mice versus elephants by simply looking at packet or byte counts. But you didn't provide a reference to anything that is a more accurate measure of elephants, or do you have such a reference?
If you're aware of other references, I would gladly include a discussion of them and analyze their similarities. I would welcome suggestions there.
Okay, Andrew, do you want to say something?
Andrew McGregor. I was just going to say it specifies non-congestion controlled for NQB. There is, I think, exactly one congestion controlled thing that could possibly go in there as well, which is DNS over TCP. Some consideration might be in order.
As in, whatever fits the behavior we want rather than how it gets there. Yeah, I agree. I agree. That's an interesting thing to look at.
Yeah, because it has the nature of very short transactions. It happens to be congestion controlled as well.
Okay, I have a question for the group. Who in the room has read the NQB internet drafts? Could you put your hand up if you've read them? Half a dozen. Okay. Of those people or anyone else, do you think this is an interesting problem? I think I'd like to take a hum as to whether the problem, rather than the draft, is something that we should be looking at further. If you think this is a useful thing to explore further, based on what you've heard today, could you please hum now? If you are unsure that this is a useful piece of work, or you think we shouldn't be working on it, can you hum now? Okay, well, we heard something.
Yeah, I think I heard some very light hums. Both of them. The interesting hum seems slightly stronger, but I think we encourage Greg to continue digging here.
Yeah, I heard good things here that I'm interested in hearing more about. So please continue to use the list. Please continue to revise. Please bring this work back.
Okay. Thank you very much.
Thank you for joining us remotely as well.
Okay. Next up, we actually have time for multipath DCCP, I think that was.
Yeah.
Let's go find those slides.
So this is individual draft. It's something a little bit different. Those of you who know my history, it's wonderful to see the word DCCP from the chair's position yet again. Although you're probably going to tell a story which is actually more useful than just reminiscing. Can you? Oh, yeah, just a minute. We need to announce one more thing. So just wait a second. The first thing that I would like to announce is that the TinyMT32 draft, which you'll remember was introduced to put a document for the code contribution from Vincent, we would like to adopt this in the working group because we've adopted the original document. So if you have comments on this, please send comments to the list. We are proposing adoption as chairs of that item.
Right. So in essence, absent comments, it will be adopted because it solves a problem that arose at ISG. The other thing to announce is the presentation you're about to see was one of about half a dozen presentations on new work or other drafts we would have liked to accommodate and can't. So I suspect we're going to ask for 4 hours next IETF.
And with that said, please take the mic.
So double click with us. You can use it. Let's just make sure. Hang on.
Okay. Hi, my name is Markus Ammann from Deutsche Telekom, and today I want to talk about multipath DCCP, which extends the well-standardized datagram congestion control protocol, and we want to use it for enabling transfer of UDP or IP traffic over multiple data paths in multi-connectivity networks, and that is also subject of 3 drafts we submitted right for this meeting.
Can you make sure you talk very close to the mic so that you pick it up remotely?
Yeah. Okay. So what is our motivation? So the main motivation are multi-access networks, which we can use to provide higher bandwidth, which we can use to provide a better quality of service, which we can use for resilience against outages. And I think a well-known multi-access network architecture is on the bottom, that it's hybrid access, which was already discussed at IETF, which provides multi-access, multi-connectivity for residential customers by combining fixed and cellular access inside a home gateway. Another motivation is multi-access networks for end devices, which is currently standardized at 3GPP release 16, called ATSSS, Access Traffic Steering Switching Splitting, and which will likely finalized this year. So that is inside the 5G standardization. So that are our main drivers at this point. And if we have a look on the traffic mix, what is currently ongoing in our networks, we see for sure most of the services or customers use IP for more or less 100%. And this divides into more or less only TCP and UDP. And for the UDP part, there has something changed over the last month or maybe over the last 1 or 2 years, and because of the QUIC. So the formerly dominating TCP has now a competitor which is called QUIC and which is transported over the UDP. So we cannot say anymore that we can use multipath TCP to cover any traffic for multipath transmission. So we need something else. So, but first of all, the demand, what we see, multi-connectivity should cover the whole IP traffic mix, in which, as I stated, TCP loses its dominating role because of QUIC. So what were our findings over the last years? So multipath TCP in principle is a good candidate to enable the TCP share for multi-connectivity. A finding from multipath TCP is that it's congestion control and power beneficial traffic splitting. Multipath support for UDP or even IP does not exist so far. UDP or IP encapsulation into multipath TCP, that was something that was discussed some years ago, is not an option as it would impose reliable in-order delivery. So a potential multipath IP or multipath UDP must not impose reliability in a sense that high latency, packet scrambling, or head of line blocking occurs extraordinary. Otherwise, we at least assume it breaks the UDP and IP principles on transportation and service expectations. Is there a question?
Yeah, I just wanted to say thank you for bringing this up. Spencer Dawkins probably is an individual on this. So the suggestion that I could make fairly early in this conversation is be thinking about whether you need multipath IP or whether multipath UDP would be everything you'd need. The high order bit for me is that this is a hard problem, and solving it once and letting transports use the one way you've solved it would be a great thing going forward if that's workable. So that could guide you towards a multipath IP idea. It could also guide you to a multipath UDP idea, since I think we've mapped every conceivable transport protocol onto UDP, except possibly UDP. So I'm not sure that it makes a difference. And at my level, I'm not sure it makes a difference which way you go, but it might be helpful to you to investigate which way to go, whether you could pick one way to go and which way to go would be best. But like I say, I'm really excited by this, and I'm the guy that chartered QUIC to do multipath mumble years ago, and we've held off on it because it's hard.
Yeah.
So if it was possible for somebody to work on this without annoying the people in the QUIC working group and every other working group that is going to want to do multipath, this seems like a really helpful suggestion, or maybe a good place to dig for a while. Thank you.
Yeah, thank you for your comment on this. But multipath QUIC or QUIC is also part of my slide set, so I will come to this right now. Yeah, why not using multipath QUIC instead? so far multipath QUIC, from at least from my perspective, is a reliable and end-to-end encrypted protocol. And its application for enabling multipath transfer for UDP or QUIC traffic only works if we apply it as a QUIC tunnel managed by multipath QUIC. So that is depicted in this picture. So I don't see any other option currently, which is mainly given by the end-to-end encryption from QUIC. And if we would do so if we would apply a QUIC tunnel to provide multi-connectivity, this would mean from the current perspective, we have useless encryption, which requires resources. If we would send UDP as guest through a QUIC tunnel, or through multipath QUIC managed QUIC tunnel, then it turns UDP into reliable transmission. If we would send even QUIC as guest, then we have encryption over encryption, then we have flow control over flow control, congestion control over congestion control, and so on. And that also fits for if we would send TCP through QUIC. Then, as I said, we have this flow control over flow control and so on. So I think that should not be the preferred way to go. Or we have to change QUIC and multipath QUIC. So that I have in the backup a slide, so you can check this offline. What we propose to change QUIC accordingly. What we propose is multipath DCCP and a framework for it. So that is subject of the 3 drafts, so maybe you can check it. So more or less we can compare it with multipath TCP. So multipath TCP managed several TCP flows. And we say now, okay, instead of using TCP, we switch to DCCP. So multipath DCCP managed several DCCP flows. And if we put this inside a encapsulation scheme, encapsulation framework, so that is a subject of the second draft we propose. Then we make it UDP or IP capable, so you can just decide by routing if you want to use the multipath DCCP. So whenever we send an IP or a UDP packet towards this virtual network interface, then we bring it to multipath DCCP. So multipath DCCP can decide where to send this packet, maybe over here this exemplary DSL and LTE. And then we encapsulate it into the respective DCCP flow based on the scheduling algorithm we apply. And then on the remote side, then we have to apply some reordering mechanisms, and that is compared to multipath TCP something new, and that is where we have to put the intelligence. And the last draft is dealing with how we can traverse middle boxes which cannot handle DCCP, and that is pretty much likely in the internet today. So most of the middle boxes we can assume will not handle DCCP, and maybe they even block it. So we found a solution, or we propose a solution to change the DCCP header. So send it through a converter, rearrange the header a little bit without losing any information, without introducing extra overhead, so that it looks like UDP, that we can traverse any middle box which exists today and which understands UDP, or at least accept UDP. So just to give you some facts or a summary of what we have already reached. So in principle, we can say this architecture is IP and UDP capable and leverage the standardized DCCP. The architecture can be applied for load balancing, for seamless handover and traffic splitting. So exactly what is addressed, for example, in this 3GPP ATSSS. It does not impose any other transport characteristic than congestion control, and that is pretty important if we talk about IP or UDP transmission. It would not be supportive if we would apply flow control or reliable transmission. It uses DCCP tunnel per path, leveraging the congestion control for efficient multipath traffic distribution. So that is similar to multipath TCP. So more or less we can state that the sender side of multipath DCCP is like multipath TCP. A prototype is available Linux-based. So we implemented everything in the in the Linux kernel. But it is not published yet, so it's just an internal prototype, and we're covering all the three IETF drafts inside this prototype. The implementation further comprises a modular scheduler scheme, as you have seen in the picture. So we have several schedulers implemented, and as I said, it's comparable to multipath TCP. And that is new. We have also a modular reassembly scheme, so we can apply different kind of reordering schemes. And that is the critical point for multipath transmission of unreliable network protocols like UDP or IP. NF3 implementation and further prototype optimization is done in cooperation with Karlstadt University and City University. So there's already something available in NF3 as well. Yeah, summary and outlook. Yeah, it is challenging, and that was, I think, what you have already stated, to develop a multipath protocol for transmission of unreliable traffic like UDP and IP. Compared to multipath TCP, as I said several times, the reordering becomes the critical part. A Linux-based prototype was developed and evaluated successfully, and results will be published soon as a paper. Independent of the multipath TCP proposal and its success here at IETF, if we would go for a quick or a multipath quick solution to cover multipath UDP transmission, the challenge for unreliable multipath quick is exactly the same, and could profit from the multipath TCP findings we already did. And my expectation today is to get some feedback from you, to have maybe an intensive discussion on the TSVWG mailing list. And maybe I have the chance at the next IETF to give you an extended presentation about what we developed, about the findings, and so on. Just before you put some questions, I just want to show you. So there is a backup slide addressing what has to be changed from our view for quick and multipath quick.
I think we should cut the slides because you're eating your own questions. Okay. Please look at the slide deck. Please give short questions or short observations, please. Go ahead.
Hi, Alan Ford, we said at the couple of slides, you've said about how reordering was an issue, but this is an unreliable transport, so I'm confused.
Where can you remember where I said
the last slide?
The last slide.
And again, Gary.
Sorry.
And again. That one. Reordering becomes a critical part.
Yeah. Yeah, sure. So in case, so let's jump back to the architecture. So in case we would send UDP traffic through this multipath TCP. And the multipath TCP splits this UDP traffic over different paths, and they have different latencies. So the packet stream gets scrambled, and we cannot assume just because we use UDP that we do not have to care about this. And so we have to reorder it to some extent, whatever it means. But I think it's not necessary to do it like TCP today.
So random order is bad, but you don't need perfect order.
Interesting semantics.
Tom Herbert. So just one quick comment on implementation. When you go to try to put this into Linux, please look at multipath TCP and the trials and tribulations that they had trying to get that into Linux. I think you'll save yourself a lot of grief if you look at that.
Yeah, thank you.
Spencer?
Specifically, I was up here to say the same thing. Specifically, the TSV Area 102 presentation about the trials and tribulations of trying to put this in the production Linux kernel. But I would start there if it was me trying to figure that out.
Mm-hmm. Okay.
David Black from the floor. Real quick comment. I heard that I think you've got a trick to make the header for DCCP look like a UDP header. If that's done, that needs to be carefully written up, and we need to allocate you a UDP service port for it.
Okay.
We already have a DCCP and UDP encapsulation, which we probably should.
Yeah,
Wait. I don't think we need to talk about this now.
It sounds like he's doing something qualitatively different. I'm going to assume he needs a service port. This is just simply a when you figure out how the hack works, write it up in detail so we can make sure that we've got something to identify this clever hack.
Yeah. Okay. As the former DCCP chair, we talked about that hacking DCCP as well. But thank you ever so much for bringing this here. I love the DCCP comeback, but I think the greater thing is underneath the idea of doing congestion control with UDP over multipath and how do we bring these together. This is a really interesting area. I encourage you to come and talk more about this, but at the moment I encourage you to go and talk to these people because some of them need to go and get some food and leave the place. I'd welcome you all back to the next TSV meeting. That'll be on Friday. Thank you for attending this time. Please bring the blue sheets to the front.